morning and welcome everyone. My name is Sunny Chen, Events Manager with MISA Ontario. Thank you for joining us for today's webinar, Zero Trust Security with the Next Gen Network Access Control. Today, we are excited to have Peter Lorpentic from City of Kitchener and Brett Hamill at Genians today. Peter is the Mobile Infrastructure Systems Specialist at the City of Kitchener since 2015. Previously network administrator at ClosetMate, he has over 22 years of experience in networking and client server technologies. He's also a CISSP with a keen interest in corporate information and cybersecurity. Brett is a Cisco CCNP and has over 25 years of experience in networking. During the last 15 years, he has specialized as an SME in designing and deploying network access control solutions. Prior to focusing on NAC, Brett served as a cryptologic technician in the US Navy, as well as providing network consulting services such as enterprise-scale WAN projects for financial institution and data center, BGP connectivity to service providers. So without further ado, Brett, please start the presentation when you're ready.
Thank you very much, Sunny. I'd like to thank MISA, of course, for this opportunity. And of course, we're especially grateful for City of Kitchener to provide us this opportunity to share our joint story. And of course, we've carved out a great partnership with Peter at the helm. So thank you to both of you for being present for this and facilitating this presentation. So let's talk about first the agenda for today. What we're going to cover today is the City of Kitchener network security challenges. So of course, City of Kitchener has their own set of challenges. Some of them may be unique, but many of them may be common to others that are attending the webinar today. We find many municipalities share some of the same security challenges. So it's a good idea to collaborate with solutions. We'll also provide an overview of Genians, the company, as well as the GNAC product. And then we will dive a little bit more deeper into the City of Kitchener specific use cases and how they addressed some of the security challenges we'll be covering. Some of the key technologies that we'll be talking about today include cloud, virtualization, zero trust, and least privilege access. So we'll go ahead and move on to the next slide. So here we just got some bullet points that Peter is going to talk to about their network cybersecurity challenges, and we'll get more into how these were addressed a little bit later in the presentation. So Peter.
Thanks, Brett, and thank you everybody for joining in this morning. City of Kitchener had network access control solution on our to-do list for a long time, but for various reasons, whether they were technical or financial or other priorities that jumped ahead, we never got around to actually implementing it. And we were kind of pushing it aside until we discovered Genians, GNAC sensor-based solution. So with COVID-19 situation, our primary goal, like everybody else's, was to quickly enable all of our staff to work remotely. And we achieved that in a very short period. But we also look at the whole situation holistically, and we said to ourselves, okay, now our people are working remotely, but what happens with all those locations that we temporarily left empty? How do we make sure that our network is fully protected and that a potential bad actor cannot simply walk into one of these locations, connect his laptop to an exposed network jack and start doing some damage? So with that in mind, our goals that we wanted to achieve with Genian and GNAC were pretty focused, clear, straightforward and I would say pragmatic, practical. We wanted to have a full visibility into every single node that connects to our network. We wanted to logically group our corporate devices and explicitly approve or disapprove them on the network. And we also wanted to detect devices that had no business being connected to our network. And we wanted those rogue devices automatically denied any access. So essentially, those were our goals, and that's why that's the motive for us to establish this partnership with Genians GNAC. And back to you, Brad.
Thank you, Peter. I think that really paints a clear picture for some of the other attendees, and maybe some of them have similar challenges along those lines. We know, especially last year, it was challenging to manage things remotely. So I'm sure some of those are common themes that are heard. So with that being said, we'll give a quick overview of our company so you know who we are. So the company is named Genians. Our main products include Genian Network Access Control and Genian Device Platform Intelligence, which we'll be talking about a little bit more today. We also offer Genian Insights E, EDR, endpoint detection and response solution as well. We were established back in 2005, and we are a publicly traded company on the Korean Stock Exchange. We have approximately 140 employees, and we are very engineer focused. So a large percentage of our employees are actually engineers, and we have 1,600 global customers. So again, we've been providing these solutions for 16 years, and just to put that in some kind of historical context relative to network access control, back in October 2004, Cisco acquired a company called Perfigo, and they eventually turned that into Cisco Clean Access, which is now today known as Cisco ICE. So really, right around the birth time of GNAC, right around when all the major large companies were also seeing there's a need for network access control, we've been in business just as long as all the major players that are in this market. So we've got a lot of good experience providing these types of solutions. We're also #1 in the South Korean domestic market regarding network access control solutions. We have over 30 partners globally in various regions. So we are primarily a partner-based model, but we also have direct engagements, such as our one with City of Kitchener. And then again, 1,600 customers around the globe. We're also named as a representative vendor by both Gartner and Frost & Sullivan. So we know a little bit about the company now. Let's talk about the Genian Next-Gen NAC product. Really, what the typical deployment looks like with Genian NAC is really these 4 phases. The first phase is one of the most important phases, which is to discover what's on your network. Often I talk with customers and partners, and we talk about, what are your plans? What kind of policies do you want to establish? And sometimes the discussion's a little bit premature because that actually happens before they actually have a proper view of the landscape about what types of devices and users are connecting and where they're connecting on their network. So any real meaningful discussion about how you're going to create policies and make decisions on security policies has to start with visibility as the core component. Once you actually know what's on your network, who and what is on your network, you can begin to categorize those devices and users and with groups and common criteria that make sense for your particular business or organization. After all, you don't want to try to talk about setting up control policies unless you actually know what kinds of categories and groups and use cases that you actually have. So once you have your visibility and you've grouped together your devices and your users, then you can say, well, now we know what kind of policies do we want to apply to control access. And only then should you have that discussion. And that's where you can decide for these types of users or devices, we will provide this type of access, and you can assign permissions and etc. And then of course, monitoring is very important. So once you set all this up, although we consider our system something that is we prefer to have set it, forget it once you get it all customized. It is always a good idea to proactively monitor and to have it set up where you can automate as much of that as possible, so you're not having to constantly go in there and check on it, but still be aware if something unusual happens or there's a violation that you wanted to be notified of, and then maybe you have to tweak your security policies. So monitoring is often overlooked as being as important as some of these other phases, but it's very critical. So we talked about how important visibility was, and how it's really the first step before you can make your cybersecurity plan and decisions on how you want to handle devices and users connecting to your network. So that is where Genian Device Platform Intelligence, or GDPI, comes into the picture. We consider this visibility 2.0, and what we mean by that is it's much beyond your legacy device fingerprinting. Historically, you would get information like this is a printer, this is a phone, this is a PC, and that just doesn't cut it anymore, especially with IoT. You need more visibility, more context. So with our device platform intelligence, we provide specific platform identity, which is lower level than just a device type. We provide context and risk for each platform that's identified. Also, the database is hosted in the cloud and has an API. So what that means is, although this is linked into Genian GNAC product, it actually is its own product as well. So we have some customers that are MSPs or other people that are interested really in visibility or understanding what kind of platforms they believe are on their network, and this critical metadata that we have, you can actually subscribe to that as a service. So it's really its own product outside of GNAC, if you wanted to just subscribe to that product. And we added over 6,000 new platforms last year alone. Now that's not like something like a finger bank where it's just a DHCP fingerprint where you could have millions. Those are very, very generic. So you're going to have more of them. This is detailed platform information. So 6,000 is a pretty significant number. So how does this break down? We provide information relative to identity. What that means is every device that connects to your network is assigned a specific platform. That platform is going to have metadata associated with it, including manufacturer, what types of connections the platform supports, and actually an image of each device. So that's a big differentiator, especially when it comes to IoT or OT, but also just having that physical image of that device really helps from a security standpoint. We also provide context. What this means is there's business information. So above and beyond the platform, we know if the platform itself has reached end of sale or end of life, and also the country of origin. Where was this platform manufactured? Then there's also risk categories. So this breaks down into technology vulnerability, and for example, associated CVEs that may affect the security of that platform, as well as business vulnerability. So is the manufacturer of the platform, are they out of business, right? We track that, or have they been acquired? Either one of those can affect whether or not that platform is being properly patched or updated or maintained. And of course, those are the only kinds of devices you want connected to your network. Once you have your visibility out of the way, you're looking at the control portion. there's just a few basic steps really when it comes down to facilitating network access control with Genian GNAC. So first, you've got dynamic node grouping, and we'll look at Kitchener's examples shortly, but really you define the specific conditions and criteria to group your devices together. And then as devices join the network, they automatically dynamically fall into those groups. Second, you define policy enforcement. So what kind of enforcement policy do you want to have, and what kind of permissions do you want to tie to those enforcement policies? And then last, you choose your own enforcement method. So unlike some solutions where you get told this is how we enforce, right? With Genians, you actually pick your method. So first, again, you have the dynamic classification. There's over 500 predefined conditions that come pre-canned in the system, or you can create your own. We've got policy enforcement based on endpoint compliance status or user. And then there's granular permissions that are tied to the enforcement policy. When it comes to actually enforcing the policy, we've got options. So we provide multi-layered security and enforcement, and you choose which option works best for you. ARP enforcement, which we'll be talking about a lot today, is one of the preferred mechanisms for enforcement among most of our customer base. And we'll talk about the reasons why that's preferred, but simplicity, ease of deployment are big factors. We also have a built-in Radius server if you choose to use Radius to enforce your security policies. We have a mirror port option as well. We have an inline enforcer option, which is a dual home gateway that you can use either on-prem or even in the cloud. We have an agent to enforce at the endpoint. You can do things such as shut off a NIC or even use dynamic rules inside of the Windows firewall to restrict access. And there's also a built-in DHCP server if you want to control access or manage a DHCP. So a lot of options relative to how you actually enforce the policies you ultimately decide on. What are the main components of Genian GNAC? So Peter is going to be talking in a moment about how they deploy Genian GNAC on their network. So before we get into that, let's make sure you understand what the components are. So there's a policy server. This is actually managed in the cloud if you desire, and that can be in a public cloud, private, or hybrid environment. You can actually install it on-prem if security policies dictate, or if you wish, you can just download an ISO image from our website, install it on a VM or on hardware. But the main purpose of the policy server is to correlate all the data from the network sensors that are distributed across the network and provide a central area for policy configuration, distribution, and centralized logging and reporting. Next, we have the network sensor. The network sensor also is delivered as an ISO image. You also can install that as a virtual instance or on hardware. Sometimes some of our customers choose small form factor hardware because it's more convenient for them if they have a lot of branches, for example. This includes platforms such as Intel NUC, Mini PC, or with small remote sites, even Raspberry Pi. There's no network integration required. It's non-intrusive, meaning you don't have to take your network down to install network sensors. And there's even a fail-safe option you can enable, which can fail open in the case of a network sensor outage. And then finally, the agent component. It is an optional component, but if you're looking for endpoint visibility control, the agent is something you would want to deploy. It can collect hardware, software, and user information. It provides 802.1x WPA2 auto provisioning, and it can also do many things on the endpoint, including things such as monitoring or prohibiting certain applications from running. And there's also a sensor option, meaning there's a plugin in the agent which allows it to actually detect other nodes on the network. So you can actually use something like a laptop to get visibility into particular network segments. So that's sort of how the main system components break down. And so I'm going to hand it back over to Peter, who's going to talk a little bit about how these different options with the cloud managed policy server, the physical and the virtual sensor options, how those are actually deployed at Kitchener. Peter?
Yeah, yes. This diagram is basically the 10,000 feet view of our Genians GNAC implementation. So as you can see here at our two main locations, we call them primary and secondary, we installed the virtual sensors, and at all other 50 plus locations, remote locations, we opted to install the physical sensors. There is absolutely no difference whatsoever in virtual versus physical sensor. It's just we have a VMware infrastructure at these primary and secondary sites, and we just opted to load the virtual sensor there, and we just install physical sensors at all other sites. So as soon as you connect the network sensor, as Brad said a minute ago, that sensor connects to the cloud policy server and starts discovery process. So basically you are in the phase one that Brad showed a couple of slides ago. You are in discovery mode. The sensor will detect dutifully all your nodes. And then at that point, you can start seeing, you have full visibility into that location. Okay, I have this many printers, this many PCs, this many access points. And then you start categorizing those. And then what I also like to use, I like word sanitation, so basically you have discovery, then you have categorization, then you have enforcement. Well, in between categorization and enforcement, I kind of wedge sanitation. So you basically have the opportunity without affecting network performance to clean your site remotely and make it pristine clean. And then when you're done and when you're satisfied, then you can just turn the enforcement on the sensor. And then from that point on, it's a game on. So it's very, very slick way of, detecting, categorizing, sanitizing, and enforcing and monitoring your nodes. So that's basically it. You can forward to another slide, or if you
Great description, Peter. One thing too to also note for if you have many locations, obviously it's not convenient to be constantly visiting locations. So one thing to take into consideration, and one of the reasons this is maybe attractive for people who have lots of branches, is you're able to actually pre-configure these sensors with a little script. So you can have 50 of these sensors, you get them all pre-configured. The person who's actually plugging it in at that predefined switch port that really is nothing but a switch port with some VLANs tagged on it, that person does not have to be a very highly technical skilled person. So it's very easy to send one of these sensors out to a particular location and tell whoever, maybe a local admin or someone there, hey, can you go plug this into this switch port? And then it'll just automatically home up with the cloud policy server. So that makes it a little bit easier because you're not running around just installing hardware all over the place. And I guess, Peter, you can talk a little bit more about the platform you ended up choosing for your sensor at your branches.
Yeah, so we purchased these inexpensive Intel NUC units. I believe it stands for Next Unit of Computing. Essentially, they're bare bone mini PC kits, and we assembled them with some DDR3 RAM and solid state hard drives. We loaded Genian's sensor image on them for each location, and we deployed them at each location. This obviously took a bit of planning and some legwork, like Brad mentioned, but at the end of the day, now we have full visibility into each and every of these remote sites. Now you can use any device, anything, even old PC. You can load an image. We would not advise you to do that. You have to select something appropriate. So we thought this mini PC kit was very appropriate for the use case. So you basically, like Brad said, you select the port on your switch at your remote location. You designate that switch and configure it as trunk port, because it's going to be handling multiple VLANs for various purpose and functions. And then the moment you connect, the moment it appears in the cloud policy server. So back to you, Brad.
Thanks, Peter. We've actually had other people actually, inquire about, the process and the platform that Kitchener has utilized because, it worked well for them. And so that's a good use case to really among MISA and really non-MISA members to talk about that use case and what platforms may work best for different organizations. So this is not a this is not a zero trust deep dive webinar. This is really about the city of Kitchener. But we just wanted to cover it briefly because one of Kitchener's goals was really to stop, just allowing devices to connect on the network by default. And so they did want to really look at some of the zero trust principles and employ some of those. So the most important thing to take away from this, really zero trust means exactly what it sounds like, right? Don't trust anything or anyone. And then even when you do, allow as little access as possible. And then a key thing is to be able to monitor after you employ it. But one thing I want to stress here is zero trust is not a product. So it is a framework. It's a set of principles. It's an approach. It's a philosophy. It's a mindset. So zero trust typically, is a combination of different products. It's a combination of security policies, a combination of technologies. But really, it's more than anything, it's a framework. So for people to follow that will, minimize your potential risk and minimize threats. So that's why it's called the model and it's a framework. So anyone who says, hey, I'm going to sell you a zero trust, appliance or something, that's not how it works. So that's the model, and what you can do is you can look at the different solutions that you're implementing, and you can actually look to follow the zero trust model and follow some of the best practices that are outlined within it. In City of Kitchener's case, as Peter mentioned, when they're, especially during COVID and everything, they just wanted to make sure that devices could just not plug in. So they wanted to lock it down. They wanted to make it where only explicitly trusted devices can connect. If you're not explicitly trusted, you will not get access. And really that's one of the key components is before something connects, right, you want to make sure you trust it. So with this ARP enforcement model, essentially you have the policy server that can be deployed in the cloud. It can be in the Genians cloud, like City of Kitchener is using, but we also have an AWS AMI. So if you have your own virtual private cloud and you want to deploy it there, you can do that as well. Obviously on-prem is an option. You can put it on an Intel platform for hardware, or you can put it on ESX. And then you have the sensors, which we've already talked about at length, that you can distribute across the network. And really, once you set your policies to default block and not trust anything, that's exactly what happens. So any new device that is connecting to the network that isn't explicitly trusted is not allowed. And we'll talk a little bit more about optional notifications for when that occurs. But some of the key factors here is you don't have to configure your switches, your controllers, your access points. I don't even know what make, model, and manufacturer switches and access points Peter has, and I don't care because it actually doesn't require it. So many times one of the first things that you deal with GNAC is, well, what is your switching infrastructure? What is your wireless infrastructure? But using the ARP enforcement, we actually don't care what that is because it is truly, it truly is vendor agnostic, which is one of the most overused terms in the industry, but it really is. So there is no network dependencies. High availability is not a huge component for a lot of our customers because you can configure it to fail open. So there's no network downtime, there's no bottleneck, and using the ARP enforcement is not in line. So high availability is just less critical than it is sometimes. You can rapidly deploy this. In 10 minutes, you can turn up a cloud policy server, and you can also image yourself a sensor very quickly too. And virtual environments are also supported. So if you have VMs out there, you can still apply policies to those because we don't need a physical switch infrastructure to enforce policy. So once you actually do stop blocking those untrusted devices by default, which is one of the major components, right, of a zero trust network access approach, you also want to do segmentation. Segmentation is the very next thing. So once you identify using your device platform intelligence what your devices are, you can create different security tags, permissions, you can configure node groups, and you can base them on those conditions. And then you can assign the least privilege required for someone to perform their job, right? So a device or a person should only have the minimum amounts of privileges on your network when they're connected. You can enforce that via the enforcement policy. And this is a key factor here. Permissions follow the node, so it's not tied to your network configuration. So if there is a certain platform type, or I have my device and I've been carved out particular permissions, it doesn't matter if I connect on the first floor or the third floor, or if I connect at City Hall or a branch, or if I connect to wired or wireless, because we're using ARP enforcement for that, it can be done no matter where I go, and it's not dependent on a network ACL or a firewall or a VLAN. Looks like, let me pause here for a second to see if we had a question. All right, so let's take a look. We've got a question here from Andrew. How does your sensor detect a new device and collect all of its attributes and fingerprints? Is it receiving DHCP requests from the devices to collect info? So that's a great question from Andrew. So the answer is no, we do not rely on a DHCP feed. And the reason we really don't need that is because the sensor is actually sitting on a port that is tagged with whatever VLANs you want to monitor. So if you want to monitor 3 or 4 or 5 or 100 VLANs, you tag them on this port. And that means that the sensor is directly layer 2 adjacent. In other words, it's inside of those network segments. It's in that broadcast domain for those different subnets. And we're listening to all of the broadcast traffic. So what we're doing is we're actually creating nodes because we see there's an IP enabled device on the network. And then we're looking at the characteristics of the broadcast traffic and other information to be able to identify what platform that is. So you're right there when you see the broadcast for DHCP, but you see the broadcast for all sorts of other traffic, you're able to make determinations based on that. So we do not require you to set up a DHCP feed, like take an IP helper and point it to us to ingest that. That's not something you have to do. So again, you don't have to touch the network to get that. And of course, we can provide deep dives as well on how that works, but that's the general answer to Andrew's question. And maybe we have another one. Let's see. Yeah. And also, you know, there's comment here that Andrew's question is relevant for new equipment deployment out of the box. It would be untrusted. So basically, you have, and if I think if I'm interpreting this correctly, a couple different ways to look at this, but your sensor is imaged and pre-configured, and then you plug it in. But for other devices, such as if you're going to take a new laptop that is freshly imaged, etc., there's ways to make exceptions for those. So you can actually make specific exceptions for those, and you can also for devices that are in the process of being imaged, right? So they're not trusted yet. And then you can also poke holes through the permissions for imaging servers, et cetera. So if there's a particular connection that a device that is out of the box and needs to be imaged, it needs to connect to an imaging server before it can be imaged and then properly trusted. You can adjust your permissions, and even you can assign specific ports or areas in your network that are designated for provisioning new equipment. Okay, so this is just a visual depiction of how the segmentation works. There's 3 very basic examples here just for illustrative purposes. Of course, you could provide as many different sets of permissions as you want, but here's a trusted guest and some kind of limited access just for illustrative purposes. And this assigns the least privilege access required for a trusted device. And then as we discussed, the permissions follow device around, and you don't have to do all these static network changes. So that's what it looks like on a diagram. And then if you look at how you actually configure that, you can define a node tag, right? Here's 3 basic examples. You add those to a group. So those node tags are conditions for a group. Then you create policies and permissions. So if you match that group, you're going to match the policy and you will get whatever specific permission that you want to assign, as long as you're matching in that group. And then of course you can test and validate and make sure as you connect these various devices that they're actually getting the appropriate tag assigned and the appropriate permissions. So we wanted to, of course, give you some visual depictions of how things look at Kitchener relative to some of the things we're talking about with grouping and everything else. So I'll turn this back over to Peter for that discussion.
Yes, so on this slide, you can see how we decided to categorize or logically group our corporate devices. So we basically created groups for access points for domain computers, printers, projectors, VoIP phones, guest devices, unknown devices, etc. And then in the second highlighted column, we defined conditions that each node has to meet in order to become a member of a group. So if you take a look at this slide, for instance, domain computers, we have 2 conditions. One condition is that detected node has to be a member of our domain. And the second condition is that we want to explicitly trust that node's MAC address. So only if these 2 conditions are met will a new node become a member of CoK domain computers. And you can see that just, you know, organizationally, I just opted to precede these groups with a dot just to group them together and then keep the rest of the out-of-box groups, you know, intact. So you can see that we have a trusted tag for our internal devices. If you look at further down, we have a group called guest devices. So if a contractor comes in with a laptop and they connect it to our network, you know, obviously it's going to be at first detected and classified as unknown device. Then our IT service staff would take a look at that device, and then if it's a contractor, if we're sure it's a contractor's laptop, we can assign a guest tag on it. So the guest tag, you can also put it on a time expiry. So you can say today from 7 a.m. to 7 p.m. this computer is tagged as a guest, and then it's going to be treated as a guest. So a little down below, I don't know if you can see it. I can only see a little bit of it, but it's a screen capture of enforcement policies. So yeah, it's down there. So basically, the enforcement policies are tied to the node group, and then you define permission for each enforcement policy. So if our newly detected node is a guest device, it will be in a guest device group, and permission allow internet only will apply. For totally unknown devices, you know, that don't meet any of the conditions, they will end up in the unknown devices group, and the permission for that policy is deny all. So basically, other than the pulse, which is IP address assigned to that device, so Genians policy server can see it, you know, that device is at the dead end. Like, they cannot touch our internal network, they cannot browse the internet, you know, and like, you, by defining these permissions, you explicitly, you know, decide what a new node can or cannot do on your network. So you can see that the guest, for instance, can browse the internet. So if he plugs into our wired network, his laptop, he can go on the internet, but he cannot touch our network, internal network infrastructure. So if a device met conditions that it's a domain computer, and we explicitly put the trusted tag on it, then at the very bottom, and you can't see that, the very last enforcement policy is a default policy with permission that allows all access. So typically our computers will, after we approve it, will fall down into that policy, and then from that point on, they're good to go. And they can move from location to location. Their trusted tag will follow them as they go to with their laptop to another location. So that's, I don't know, Brad, if you have anything else to add.
No, I think that was great, and we also want to include a dashboard view here, and to show what this looks like after you configure it and nodes start showing up in the dashboard. So Peter, you can talk a little bit about that.
Right. This is what our IT staff sees when they log into the cloud policy server. So this dashboard is very customizable. So we opted to have instant visibility into obviously unknown devices and guest devices. Also worth mentioning is that you can set up a different management scope for different teams in your IT. So for instance, when our IT service desk staff logs into the cloud policy server, they may not see the total number of 3250 of all nodes, and they may not see like 5 unknown devices. They may see 2 or 3. And that's because we set up their management scope to be just for PCs, printers, VoIP phones, pin pads, projectors, and whatnot. And then when our network specialists log in, they can see the full number of nodes, 3250 at this time on this slide, and the 5 unknown devices. So basically, we are providing access and visibility on a need-to-know basis. So we don't want the IT service desk staff to inadvertently approve or disapprove a firewall or a router or a switch. So they see what they need to see. And at the bottom, again, I don't know if you can see all this. At the bottom, you can see the content of our unknown devices group at the time when we took this picture. So you can see that there are some interesting devices that connected to our network. Somebody attempted to connect Samsung TV, straight to our network. And then another one down below is somebody brought Magic Jack. That's a VoIP phone, and this very phone, the first record, is also some sort of a VoIP phone that we had no visibility into this before we had Genians. So people could connect, and then not necessarily with bad intentions, but we just don't want these devices to be connected to our network, period, right? There is one device here that was actually a legitimate device, and that's this PC with the host name PC2123. As you can see, it was detected that it's a member of the main, but it's missing a MAC tag, trusted MAC tag. So it was missing the second condition. So like we said on the previous slides, we initially explicitly approved all the nodes on our network. So once we put the trusted tag, MAC tag on this PC, then it just instantly disappeared from the unknown devices and fell into the default group, which is permit all. So that's basically.
That's a great overview, Peter.
Very like a granular visibility and control at your fingertips. So
sure. Great explanation, Peter, and overview of that. We got a couple of questions that came in the meantime. One is from Fabio, and it says, can you explain or show how Genians can make the difference between an internal network and the internet? We need to make this configuration somewhere. And then we have another question that is, well, let me do this because we actually have a few questions coming. So let me answer Fabio. So we don't actually have a screenshot of the network object, but to answer Fabio's question, these permissions here that you see under the enforcement policy, those are tied to network objects. So you define your internal network address space and you exclude it, and that will give them internet only, or you can give them all, or you can only give them access to certain subnets. So it actually doesn't list as a column here, but each permission is tied to a logical network object, and that's how you define what the permissions will be able to access. We have another question from Young, and it says, it seems that this product is based on MAC address. Is it capable of controlling network access based on user and application as well? So the answer to that is yes. So there's different ways that you can employ this. We're showing examples for that include some MAC tagging, but that is just one approach. So you can actually import users from something like Active Directory. You can create user groups, and you can then tie user groups based to different permissions, regardless of the MAC, right? So they could be on one or two or three different machines, and the permissions can follow the user. So you don't have to use the MAC as part of your policy configuration. And there's another question here. What do you do with BACnet, et cetera? That's a great question. So we actually do have, if you go to our website and look for device platform intelligence, we have a lot of OT categories in there, and you can search through those. But a BACnet is something, so I sort of demonstrated that with the limited OT tag here. So you could have something like this, which I actually think might even be a picture of a BACnet router. And you can actually limit it to only one other internal server, so highlighted in blue, one other internal server that it may communicate with and nothing else. So you can, create OT type specific policies. And we don't necessarily, there's another question from Brent. We don't necessarily use IFMap, so we don't use that. So it's just not part of the architecture. So we have feeds coming in from the information that we're seeing, and also our sensors can go from a monitor to an enforcement mode, and can also do some active scanning with Nmap and some other things. But if map is not one of them.
We
So
actually do have some building automation and control devices at City of,
okay.
but they are, they have their own dedicated VLAN, and that VLAN is added to the sensor where it's needed, and that's how we detect the building automation equipment. So
Sure.
as long as it's visible on the network, the Genians
Right.
sensor will pick it up.
Well, we talked about how important monitoring is. Well, monitoring is something that's very important. So we've got anytime a new device or a new platform is detected, or an enforcement policy is changed, or really any kind of log filter that you want to set up, you can actually configure notifications. So here's just two examples of different log filters that you could set up for either a new platform is detected, or if an enforcement policy change. You may want to know if a node was matching on one enforcement policy and then starts matching on another enforcement policy. That might be something of interest to you. And these can get as granular as, every single time a new device connects, right? Or you can make them more complex. But it's important to actually monitor. And then what you can do with this is so you don't have to constantly be in here looking at logs, you can actually set up different actions. So every time something happens, this is a very simplistic log filter if a new MAC connects to the network, but every time something happens, you have multiple options of what you can do. So here's just a couple of them highlighted. You know, you can email or SMS your network admins. You can actually do a webhook to something like Slack or Teams. We actually have a video on our website to show you how the Slack integration works, and a device that meets whatever criteria in a log filter can automatically populate a message in a Slack channel. And then you can also assign tags. So you can have, if a particular filter occurs, like if you get a feed in from a SIM or some other IDS that's on your system and a threat's detected, you can dynamically assign a tag indicating that a threat is detected on that node. And then wrap this up real quick, and then looks like we have some other questions coming in. This is sort of just a visual picture of what some of these notifications look like. So whether it just be anything that is occurring natively or organically inside of Genians, like a new device connecting or something, or an enforcement policy changing, or if it's something more like you know, an IDS or a SIM sending alerts and threat information to Genian GNAC, and then it sending notifications out, you have a lot of options here, and being able to, you know, open a ServiceNow ticket or send a message to Teams or Slack or email or SMS. The great thing about that is it's just a notification that something happened, but you don't need manual intervention. That's just telling you that Genian's already performed an action, quarantined a node, and it's just an FYI. You don't have to run and drop what you're doing and do something. So I'm going to jump into some questions here. Okay. Yes, we definitely can share the presentation deck afterwards. I also believe potentially we could be recording the webinar, so absolutely. Young for that. And then Kadar is asking, how do you achieve device authentication use case, AAA use case? So you can actually do authentication with Radius if you prefer. If you recall earlier on in the presentations, one of the things I said is there's a built-in Radius server. So if you're more familiar with Radius, you're comfortable with Radius, you like Radius, you don't have to use ARP enforcement. You can actually use Radius to do all, you know, MAC authentication or EAP-PEEP or EAP-TLS. Any of those would work. Or you can combine the two. A common option is you could use Radius for authentication, but then you can use ARP enforcement for post-authentication access. And yep, so Radius authentication use cases, many of those also on our website, and it's not the focus of this webinar, but I have videos and actually webinars that are very specific to Radius use cases. So we can meet them all, including VPN Radius authentication. And then from Mark, we have, what is the process for adding a computer to the domain if it is not trusted by default? And I think one of the things I talked about a little bit earlier, Mark, was that you can actually make exceptions in a couple different ways. So if you have something that needs to join the domain and it's not on the domain yet, you can make a MAC exception for it when it's first coming up after it's being imaged. So you can configure your policies however you want for those devices that are brand new devices that are being onboarded. So
in our case, we basically, when we image the new computer, we just open up the console and we just quickly approve we put on the new machine, and you're done with it forever, right? We were toying around with the idea of creating a separate VLAN to kind of as a landing stage for the new computers, and we may still go ahead and do it, but for now, like we just simply open up a console when we're imaging 10 new machines. We have them all 10 caught in unknown group, highlight them all, we put the trusted tag, and you continue with your imaging process.
Great. And I know we're coming up close to the top of the hour here. Brent also asked if we work with Owl's products, so I'll have to take a look at that product. But really what you're seeing here is we've actually got an external systems integration page on our documentation on our website that shows all the different external integrations we do. They're not proprietary, so they're based on syslog or API. So they're, you know, both of those can be used. So really any system that's capable of sending a syslog or a system that's capable of integrating, we have a REST API that City of Kitchener is not using, but it's there built into the GNAC. So many external systems we integrate with can use the REST API to perform actions inside of GNAC via the API, and also can list information. And in fact, we also have another video of that on our website as well. Lots of videos on our website. And so I know Sunny's reminding me that we're wrapping up, and that hour went by fast. So here's a slide. Do you have any questions, maybe specific to City of Kitchener's challenges or solutions? Obviously, you can reach out to Peter. He'd be happy to share his story. And then, of course, you can reach out to Genians for any other questions. This was a very specific webinar, focused on their use cases. But if you want something more specific to a certain use case, Radius, something else, just let us know. Send us a note at hello@genians.com, and we can set up a webinar or direct you to the correct resources.
Thank you, Brent. So we still have a couple minutes. So attendees, if you have any questions, please feel free to enter in the chat window. And also, if you like to, you can also raise your hand and I can let you talk and ask questions through your audio. So perhaps we'll just give it a couple seconds to see if we have more questions. So just a reminder for everyone that I will send a follow-up email, including the access to recording to this webinar on our website, and also the contact information of Genius, so you can reach out to them directly if you have any further questions. So it looks like we are good with the questions. So Brett, thank you so much for bringing up the questions and answer them as we go. I think that's wonderful. Do you have anything that you would like to add before we end today?
Just again, one more thank you to Peter and his efforts. And really, I think he did a great job of leveraging the solution to meet his use cases, and just does a great job of being able to explain and elaborate that. So thank you again, Peter. And of course, thank you, Sunny. Just, for us, we're here to meet any different kind of use case. So just, give us a shout if you need anything, and we can carve out some time for you.
Thank you for you both for contributing to such a great presentation. We had lots of engagement today. That's wonderful. So everyone, look out for the follow-up email. And thank you again for joining us today. Have a great day. Bye for now. Thank you, Brett and Peter.